Recently, viewers have been requesting videos covering how to work with binary files using C. So in this video, we're going to learn the basics of accessing binary files using C. So first off, what is a binary file? What does that mean? So a normal text file is made up of characters. So everything in a text file like this is a character. Now, ultimately, all information on a computer is represented as bytes, which are made up of a series of bits, which are zeros and ones. So for example, in a text file, the character 0 might be represented with the number 48, which is itself represented with this byte here and these 0 and 1 bits. And the number 1 might be represented with the number 49, which is itself represented with this byte here with these zeros and ones. So if we had a number like 1 billion here, where we have the number 1 followed by 9 zeros, each one of the characters in this number is going to have to be stored. So it would look like this. We would have the 1 followed by the 9 zeros, all stored using these 10 bytes to store each character, the 1 and the 9 zeros. And the way that characters are represented with bytes can actually be different too. So it might actually require more space than this too. So while a text file uses bytes to represent characters, a binary file stores the number directly using bits, the same way that the number is stored as an integer value in a C program. So if we stored the number directly as an integer, it would look more like this. And it would only take up 4 bytes total. So because we're storing the number directly in the way that our computer stores a number, rather than storing each digit character of the number individually, it ends up taking up less than half the space as a text representation. So one of the big benefits of storing data into a binary file instead of a text file is that it may take up far less space this way. Another big benefit of storing data using a binary file is that it may also be much faster to read from the file and write to the file. Because with a text file, we'll need to convert our data into characters, or convert the character representation of our data into numbers or whatever else is used to represent our data. But with a binary file, we store our data and retrieve our data from the file using the exact same format used by our C program. So let's go over an example of writing to a binary file and reading from a binary file. So we'll write a program in this file here. And the first thing we'll do is create an array of data to write to the file. So here I'll say int data is equal to, I'll just put in the numbers from 1 billion to 1 billion 9. Now to actually open up the binary file, we'll need a file pointer. So I'll say file star file. Once we open the binary file, we can write to it. We do have to open up the file in a particular mode though. So here I'll say file is equal to fopen file.bin wb. So fopen is going to open up the file called file.bin. And the mode it's going to open it up in is this WB mode, which means write to a binary file. Now, if fopen can't open the file, it's going to return null. So we'll check to see if file is equal to null before we proceed. So we'll say if file is equal to null, something's gone wrong. So we'll say printf error opening file. We'll return 1 to terminate the program. And we're going to return 1 because returning 1 is a signal to the shell here, to the terminal, that something went wrong in the execution of our program. So now that we know we've opened the file correctly, we're going to write to the file. And we'll use fwrite to do that. So we'll say here fwrite data, size of data, 1, and file. So the way that fwrite works is that it's going to write the data contained at this memory address to this file. And it's going to write this amount of data this many times. So in other words, this amount of data multiplied by this number here. So in this case here, we're going to write the entire data int array to the file. Now technically this first argument here is a pointer. In the case of an array, in this instance, we say it decays to a pointer when we use it like this. So now we can close the file because we're done writing to it. So we'll say fclose file. So now we'll save and compile this program. So we'll say gcc-o ww.c. And then if we run the program, we'll have a file called file.bin here. If we try to open up that file in a text editor, we kind of get this error message here. I'm using Visual Studio Code. I installed an extension that helps me to visualize binary files, but you can already see we can't really read it like a normal file. If I right click and then I go to show hex dump, this will give me some sense of what's in the binary file. So even though this data requires some interpretation, it is possible to visualize the contents of a binary file in different ways. Let's actually read from the file though next and print out the data after we read from the file. So the way that we're going to read from the file is going to be very similar to how we wrote to the file. So I'll actually just copy and paste this here. And I'll make a new file here called r.c. And this program is going to be for reading from the file. So I'll make an int array called data. And our int array is going to be able to hold 10 integers. We're going to open up the file again. This time we're going to say rb, because we're opening up the file for reading this time. We'll still check the file to see if it was opened correctly. Instead of fwrite, we're going to have fread. And other than that, it's kind of the same. So fread is going to read from this file and store the data from that file at this memory address. And it's going to read this amount of data this many times. So in total, this amount of data multiplied by this number. And then we'll close the file here. Now, if we actually want to see if we read the data from the file correctly, we should print out the contents of the data array after we've read the data into it. So here we'll have a loop. We'll say for int I is equal to 0, I is less than 10, I++. And we'll print out the elements of data. So we'll say printf data %d is equal to %d \n, and we'll output I and data at index I. So if we save and run this, it should actually read from the file now, store it into a data array, and then we'll print it out. So we'll say gcc-o r.c. And then if we run the program, we get those 10 numbers there, from 1 billion to 1,000,000,009. So that's the basics of writing to and reading from a binary file. But I had mentioned how binary files could be smaller than a text-based equivalent, and I had said the performance could be higher. So let's go over an example that will demonstrate that. What we'll do is write 1 million numbers to a file, and we'll read those 1 million numbers from a binary file. But we'll try to do the same thing with a text file, so we can see the size difference and the performance difference. So in our write file here, instead of this int data array here with 10 numbers in it, I'll make a new one. The new data array is going to have 1,000,000. So we'll say 1, 1, 2, 3, 1, 2, 3. And we'll use a loop to fill this array. So we'll say for int I is equal to 0, I is less than 1,000,000, I++, and we'll say data at index I is equal to, and we'll have 1 billion here. So 1, 2, 3, 1, 2, 3, 1, 2, 3, plus I. So very similar format as before. We're just going to continue on up until 1,000,000 here. So then we'll write the data to the file the same as we did before. Now in our read program, we're going to have to make some modifications here. So in our read program, we're going to have 1 million elements in our data array. So I'll add some zeros here. We'll actually take out this code here where we print out the million elements. That's quite a bit to print out. But other than that, this should be good. This should read in those 1 million integers and store them into the data array. So to help us do a performance comparison, let's make a program that will read 1 million text-based integers from a file called file.txt. So here I've got a file called big.txt. And inside big.txt, I actually have 1 million integers. And they're the same integers as we're writing to the file.bin. So I'll copy this, and I'm going to paste it into file.txt here. And then I'll save this. So now we have a text-based equivalent to the file.bin file that we're going to be creating. So what we're going to do now is make an equivalent program to actually read those 1 million integers that are stored using characters. So I'll make a program called t.c, and it'll have a somewhat similar format. So here I'll say int data 1 million, because I still have to store 1 million integers. When we open up the file, we'll open it up for reading, and I'll say file.txt. So I just have R here because it's not a binary file, it's a text file. So because it's a text file, we're going to have to actually convert the characters stored in that file to their integer representation. To do that, I'll include stdlib.h, because there's a function in there called atoi that allows us to convert that string character-based representation of the number to an actual integer that we could store into the data array here. So down here, instead of fread, I'll say car buffer 100. And this character array buffer is where we're going to store each line of this big.txt file as we read them in one at a time. And we're going to be storing a string into that buffer character array. We'll then use the atoi function to convert that string to the integer so we can store it into the data array. So here we'll say for int I is equal to 0, I is less than, we'll have 1 million here. And we know there's 1 million lines in this file, so we can just read from it 1 million times. And we'll say fgets buffer 100 file. So this is going to read from the file the next line up to 100 characters, and it's going to store the string into buffer. Then we'll store into the data array at index I the converted value. So we'll say atoi, and we'll convert the number stored in buffer to the integer that we're going to store into the data array at index I. And this should do it. We now have a program that's going to read in the same numbers when they've been stored in a text file. So let's do some comparisons now to see the space difference in terms of the memory required and the time difference in terms of performance. So first, we're going to run our program that's going to create the binary file. So here we'll say gcc-o w.c to recompile the program. And we'll run it. We'll say /w. So now if we do ls, we'll see that we have a file.bin. Let's compare the size of that file to file.txt, because both file.txt and file.bin are storing the same 1 million integer numbers. So if I say here ls-s, notice that file.bin is less than half the size of file.txt. So to store the exact same numbers in a binary file is less than half the size. So we can definitely see the performance difference in terms of the memory requirements. Next, let's look at the performance difference in terms of the time to read the files. So we'll compile our r.c program again, and we'll also compile our new t.c program. First, we'll run the t program that reads from the text file. So we'll say time./t. And we get here 0.322. We could run it a few more times to get a sense of how long it's going to take. We seem to be getting numbers like 0.09 something, roughly around there. We'll try the same thing now with the R program that reads from the binary file. So we'll say time./r. And we seem to be getting much lower numbers here. Let's try one after the other. We'll say r and then T. R, and then T. R, and then T. And if we take a look at these numbers here, we're going to find that the binary file is being read 10 times faster than the text file. Because here with the text file, we have 0.096. With the binary file, we have 0.011. With the text file, we have 0.104. With the binary file, we have 0.11. And in this case here, with the text file, we have 0.097. And with the binary file, we have 0.009. So roughly 10 times faster. So even though our little experiment here is pretty informal, with a binary file, we're using less than half the space, and our performance is roughly 10 times faster. Those are not insignificant numbers. So you can definitely see how there would be advantages to using binary files. So this has been the basics of using binary files in C. We'll cover more examples in future videos. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.